Homework 10.2 is writing systems of equations. And I'm going to do a bunch of examples here to make sure we know how to write these, because this is pretty important and you will not pass this test if you can't write them. You won't even come close. So this first one, a triangle has one angle that measures 3 more than twice the smallest angle, 49, and is 49 degrees less than the largest angle. So the first thing we need to do when we are writing a system of equations is defining our variables. Clearly the thing that we're missing here is what the angles are. There's some sort of triangle, and there are 3 angles. Those will be our 3 variables. I will use A for the smallest angle, B for the middle angle, and C for the largest angle. And these are the, it's actually, smallest angle isn't a great variable. It should be measure of the smallest angle. How many degrees the smallest angle has, how many degrees the middle angle has, how many degrees the largest angle has. So measure of the largest angle, measure of the middle angle, measure of the smallest angle. So now let's look at what they tell us. It has one angle that measures 3 more than twice the smallest angle, and is 49 degrees less than the largest angle. So they're talking about the middle angle. The middle angle, B, measures 3 more than twice the smallest angle. So B is 3 more than, means you're going to add 3 to twice the smallest angle. So the order we do this in is we do 2 times the smallest angle, and then we add 3. 3 more than twice the smallest angle. It also says it's the middle angle is 49 degrees less than the largest angle. So B is, the middle angle is 49 degrees less than the largest angle. 49 degrees less than means we need to take away 49. Note, this is not 49 minus C. That's bad. 49 degrees less than means you take away 49 from the thing it's less than. So 49 minus C is wrong, C minus 49 is right. But this is only 2 equations, and we have 3 variables. When we have 3 variables, we need 3 equations. But there's no more information to give us. The last piece of information sometimes has to come from your own knowledge. When we're talking about 3 angles of a triangle, we know that all 3 angles must add up to be 180 degrees. So this is my system of equations. All right, let's try C. This is a pretty straightforward one. Jeanette, Raj, and Henry go to a Chinese restaurant for lunch, and they order 3 different luncheon combination platters. Jeanette orders this stuff, Raj orders this stuff, Henry orders this stuff. Jeanette's platter costs $5, Raj's costs $5.25, Henry's costs $5.75. How much does one portion of chicken chow mein cost? Sometimes the question can be a clue to what the variables should be in the system of equations. Well, one of the variables is going to be how much one portion of chicken chow mein costs. So one portion of, I'm just going to call it chicken chow mein costs, and I'm going to set that equal to a variable. Whatever that costs, that's going to be, I'm going to call it C. I also need to know what one portion of fried rice costs. I'm going to call that R. And broccoli. One portion of broccoli. I might have spelled broccoli wrong there, I don't know. So the cost of one portion of chicken, the cost of one portion of rice, the cost of one portion of broccoli, these are the variables here. Notice if you just put rice, chicken, broccoli, it could be how many portions you had, what's the weight of them. But in this case, the actual variable represents how much one portion costs. Now that we have our variables defined, we can set up an equation. Jeanette ordered 2 portions of fried rice, 1 portion of chicken chow mein, and her total cost was $5. So 2 times however much the rice cost plus 1 times however much the chicken cost had to add up to be $5. She ordered 2 orders of rice and 1 portion of chicken. And remember, R is the price of one rice. C is the price of one chicken. So 2 times the price of one rice is how much she spent on the rice. I didn't put 1 times the chicken because 1 times anything is just itself. All right. Raj ordered 1 portion of fried rice, 1 portion of chicken, and 1 portion of broccoli, and the price of this plus the price of this plus the price of this had to all add up to be $5.25. The last thing is Henry, and Henry ordered a portion of broccoli and 2 portions of chicken. And that is $5.75 when he adds those up. Now, you may have noticed I put these last 2 in a weird order. It said he ordered a broccoli and 2 portions of chicken, and I put the chickens first. The reason is it's helpful to have all the variables lined up. So I did my R's first, my C's second, and my B's third. That's a useful strategy, and you'll see later in this unit why that's important. All right, this is a kind of more complicated one here. A movie theater charges $7 for adults, $5 for children, and $4 for seniors. One showing of the theater sold 222 tickets and took in $13.83. Twice as many adult tickets were sold as the total of children and senior tickets. How many of each kind were sold? Okay, again, if you can't tell what the variables are the things that we don't know, you can often get it from the question. How many tickets of each type were sold? So the variables are going to be the number of adult tickets, the number of child tickets, and the number of senior tickets. I guess I'll choose A, C, and I'll use a script S. I really hate S's, but senior, my S's look a lot like 5, so I try not to use them. So, let's see what we know. They charge $7 for adults. Let's put all our adult information together. They charge $7 for adults, and that's really all we know. So, let's see. They sold 222 tickets total. That's the number of adult tickets plus the number of child tickets plus the number of senior tickets. So A plus C plus S equals 222. That's the total number of tickets. It says the total price was $13.83. Well, the total amount of money it's going to be is, we know it's $7 times however many adult tickets they sold, plus $5 times however many children tickets were sold, plus $4 for however many senior tickets were sold. Because it told us the price of each one, so we can figure out the total amount of money from each one, and that total amount of money had to add up to be $13.83. The last thing is, it says twice as many adult tickets were sold as the total of children and senior tickets. So, the order of this is weird. You have to really think about it. The number of adult tickets is going to be twice as many as the other two combined. So the number of adult tickets is 2 times, what's it 2 times? Well, it's 2 times the total of children and senior tickets. So you have to add the children plus the seniors together like this. We could have also we could have distributed here and said 2C plus 2S. Either one of these is fine. Notice we have 3 equations for our 3 variables. All right. You know, I think I'll leave you H. This is getting kind of long already. I want to go to J. J says, your aunt receives an inheritance of $20,000. She wants to put some of the money into a savings account. She wants to put some of them into CDs and some of them into bonds. A broker tells her that CDs pay 5% annually and bonds pay 6% interest annually. I guess this earned 2%. She wants to earn $1,000 interest per year, and she wants to put twice as much money into CDs as bonds. How much should she put in each type of investment? Okay, so again, this is the clue for what the variables are, is how much she's putting in each investment. So the 3 types of investments are the savings account, how much she puts in CDs, and bonds. So how much she put in savings account, how much she put in CDs and how much she put in bonds. I'm going to call this S, I'm going to call this C, and I'm going to call this B. So let's see if we can come up with some equations. This is the total she put in savings, the total she put in CDs, the total she put in bonds. Well, she wanted to use the whole 20,000, so we know that this plus this plus this has to be 20,000. How much she put in savings plus how much she put in CDs plus how much she put in bonds had to be 20,000. The next thing is, it says she wants to earn, this is the hardest part. This is why I'm doing this example for you. She wants to earn $1,000 interest per year. Well, how does she earn interest? Well, she gets money from each one of these. And the amount of money in interest she will get from her savings account at the end of the year is 2% times however much she put in savings. 2% of this is the interest she gets from savings. 5% of the CDs is the amount she gets from CDs. And she gets 6% of bonds. And that needs to add up to $1,000. So that's her second thing. This is the interest because you get 2% of what you saved. You get 5% of what was in CDs. You get 6% of what was in bonds. And that total interest had to add up to $1,000. The last thing is she wants to put twice as much money in CDs as in bonds. So the CDs have twice as much as the bonds. How much she puts in CDs has to equal 2 times the bonds. Okay, that's all. I'm going to skip the orchestra, I think. Let's go to this parabola one. A parabola goes through the points -1, 2, 1, 8, and 2, 5. And what this comes from is, you know the general equation of a parabola. A parabola is y equals ax squared plus bx plus c is the general quadratic equation. Note that there are 3 variables we would need to be able to find to be able to figure out what the equation of the parabola is. And they give us 3 pieces of information. They give us an x and a y, an x and a y, an x and a y. For this first x and a y is 2, x is -1, for this second x and a y is 8, a is 1, and this third x and a y, x is 2, y is 5, and this gives us 3 equations with the 3 variables we wanted in them. Notice x and y are not in there. We plugged in x and y and we're left with these 3 equations. We usually simplify this. This is 2 equals -1 squared is +1. +1 times a is a. B times -1 is minus b plus c. 1 squared is 1. 1 times a is a. 1 times b is b. And then c. And the last one is 2 squared is 4. 4 times a is 4a. B times 2 is 2b plus c. We have these 3 equations with 3 variables in them. And so it's pretty easy if you know what you're doing. You know, you didn't have to use this. You could have just as easily used y equals a times x minus h squared plus k. Notice you would have 3 equations with 3 variables. You'd have a, h, and k when you plugged in x and y, a, h, and k. And this is also an appropriate way to solve for it. You could have also done it another way, using your factored form. All right, I'm going to do one more. A line with a slope of 2 and a y-intercept of 1, and a line with a slope of 3 and a y-intercept of -4, and a line with a slope of -1 all intersect at the same point. What is the y-intercept of the third line? I'm going to start writing what I know. A line with a slope of 2 and a y-intercept of 1. That's y equals 2x plus 1. A line with a slope of 3 and a y-intercept of -4. 3x minus 4. and a line with a slope of -1, but they didn't tell me the y-intercept. So I'm going to put plus b. They all intersect at the same point. What is the y-intercept of the third line? This is the variable we're solving for, but notice there's an x and a y in each one of these. So these are my 3 equations with 3 variables. So here, x and y are the intersection point, and that has to be the same x and y for all 3 of these because they all intersect at the same point. And b is the y-intercept of the third line. Okay. That's it. Hopefully that helps in your homework.